On June 11th, 2026, the nation's weather forecasters made it official. After months of watching the Pacific, they declared that El Niño had arrived. El Niño is a warming of the tropical Pacific Ocean, far out near the equator, and it has a long reach. When that water heats up, it changes the winds above it, and those changes carry all the way to the United States. What stands out this time is the speed and the strength. The Pacific flipped out of its cool phase and into this warm one in just a few months. The water in that key stretch is now running about 3 degrees Fahrenheit above normal, and the forecast calls for it to keep climbing through the winter, possibly to a level reached only a handful of times in the record. If steady, clear reports on our changing weather are useful to you, subscribing keeps them coming. This report follows the whole story, from the first warm signals out in the Pacific to the grip El Niño holds today, and on into the winter, when its effect on America is expected to be strongest. The word came on a Thursday. On June 11th, 2026, the country's main climate forecasters posted a short notice, and the notice carried a plain phrase: El Niño conditions are present. 4 quiet words, and they marked a turn in the season for the whole country. That kind of notice has a name. Forecasters call it an advisory, and it means one simple thing. The pattern they had been watching for is no longer a forecast. It is here, and it is expected to stay. For months the language had been careful and full of maybe. On that day the language changed. El Niño had arrived. It helps to say plainly what arrived. El Niño is a warming of the surface waters across a wide band of the tropical Pacific Ocean near the equator, thousands of miles from the United States. The water there is normally a certain temperature for the time of year. When it runs warmer than normal for long enough, and the winds above it shift to match, forecasters call the pattern El Niño. The reason a warm patch of ocean earns a national notice is reach. That part of the Pacific sits under some of the most active air on the planet. Warm water there feeds tall thunderstorms, and those storms nudge the winds that steer weather far downstream. A change out on the equator does not stay on the equator. It travels, and some of where it travels is here. So the announcement was less about the ocean, and more about the months ahead. It was a signal that the odds for this coming fall and winter had shifted. Certain outcomes across the United States were now more likely than they were a season ago, and certain others less likely. The advisory was the country's forecasters saying, out loud, that the deck had been reshuffled. There is a calm honesty built into how they say it. They did not promise any single storm or any single dry month. They said the pattern is present and expected to continue, and they let the odds speak. That is the right way to hear it. El Niño loads the dice. It does not throw them for you. The timing of the notice was not random. The country's forecasters review the state of the Pacific on a set schedule and share a full discussion once a month. This one landed in the second week of June, and it moved the official status from watch to advisory. A watch means conditions look favourable for El Niño to form. An advisory means it has formed. Crossing from one to the other is the moment the season turns official. What made this particular crossing worth a closer look was how fast it came. Not long before, the Pacific had been in its cool phase, the mirror image of El Niño. The ocean cooled, then levelled off, then began to warm, and the warming did not stop. In the span of a single spring, the equatorial Pacific went from cool to neutral to clearly warm. That is a quick handoff, and forecasters took note of it. The other thing worth noting is direction. The advisory did not describe a pattern near its end. It described one still building. The water was warm and getting warmer, and the outlook called for that climb to continue for months. In plain terms, the country met El Niño on the way up, not on the way down. The strongest effects were still in front of it. That is the heart of why this report exists. An El Niño that is present and strengthening is a story with a long middle still to come. Its clearest mark on American weather tends to show up in winter, and winter was still half a year away. The advisory was the opening line, not the last page. For most people, the day itself changed nothing they could feel. The sun came up, the local forecast held, the week went on. That gap is normal and important. El Niño works slowly and at a distance. It shows itself over seasons, in the tilt of the odds, not in a single afternoon. The announcement was a heads-up about a pressure being applied far away, one that takes time to arrive. So the country now sits at the start of an El Niño year, With the notice on the record and the water still warming, the next question is a natural one. What exactly did forecasters measure to say the word, and how warm does the ocean have to run before a warm patch becomes El Niño? That measurement is where the story turns next. Every El Niño call comes down to a number. Before the advisory, before the discussion, there is a temperature reading from the ocean, and that reading either crosses a line or it does not. The line is not a matter of opinion. It is a fixed threshold, agreed on long ago, and the whole system rests on it. Here is the line. Forecasters take the surface temperature of a set piece of the tropical Pacific and compare it to the long-term average for that time of year. The gap between the two is what matters. When the water runs about 1 degree Fahrenheit above its normal and stays there, the ocean has met the El Niño mark. Below that, the pattern is neutral. Well, below it, in the other direction, is La Niña, the cool phase. The number that carries all this is an average, and averages hide the swings inside them. So forecasters also watch the water week by week, which moves faster and shows where things are heading. In the middle of June, one of those weekly readings came in near 3 degrees Fahrenheit above normal. That is a strong figure. It sat well past the mark, and it was still rising. To reach a single trustworthy number, forecasters lean on more than one thermometer. Ships, drifting buoys anchored across the equator, and satellites overhead all report the sea surface temperature. Those streams get folded together into one clean measure for the region. The result is a value updated constantly, checked against decades of records, and treated as the official pulse of the Pacific. One reading alone does not make an El Niño. The ocean can warm for a week and then settle back, so the rule asks for persistence. The warmth has to hold across a season, not just a spell, and the atmosphere above has to respond in kind. By June, both boxes were checked. The water had been climbing for months, and the winds had begun to shift with it. That is why the call was made when it was. It is worth pausing on how small these numbers sound and how large they act. A single degree Fahrenheit does not feel like much to a person standing in a warm room. Spread that same degree across a slab of ocean the size of the continental United States, and it becomes an enormous store of heat. The Pacific is vast, and vast things move slowly and carry force. A shift of a degree or two across that surface is a change measured in staggering amounts of energy. That is the quiet reason a modest-sounding number matters so much. The atmosphere runs on the heat it draws from the ocean. Warm the ocean surface over a huge area, and you hand the sky more fuel in one region and less in another. The air responds by lifting in new places and sinking in others, and the whole weather machine leans to follow. The number is small on a thermometer and heavy in its effects. Forecasters also sort El Niño by how far past the line the water climbs. A reading a little above the mark counts as weak. Higher, and it becomes moderate, then strong. Push the season-long average up near 3.5 degrees Fahrenheit above normal, and forecasters use the word super, reserved for the biggest events. Where the ocean tops out decides how firmly the pattern grips the year. By the time of the advisory, the reading had already carried the season past week. The water was warm, the trend pointed up, and the outlook called for the average to keep rising through the fall. That is the setup that made this event stand out. It was not hugging the line, it was climbing away from it. None of this fixes any single day of weather in advance. The number is a measure of pressure on the system, not a script. It tells forecasters how hard El Niño is likely to lean, and for how long. From there, the odds for rain and heat and storms shift by region and by season, in ways the rest of this report will follow. So the call rests on a clear reading, well past the mark and still climbing. The next natural question is about place. This warmth is not spread evenly across the Pacific. It lives in one particular stretch of water, watched more closely than any other, and that stretch is where the story goes next. There is one rectangle of ocean that the whole world watches. It sits along the equator in the central Pacific, far from any coastline, a long way east of the islands and a long way west of South America. Forecasters gave it a plain label years ago, and the temperature inside it is the single most important reading in the seasonal outlook. The rectangle is wide. It runs for thousands of miles from east to west and stays close to the equator, north and south. Picture a band of open water broad enough to swallow the United States several times over, all of it centered on the line where the sun stands most directly overhead. Nothing about it looks special from a ship. Its power is in its position. Position is everything here. The equator receives more direct sunlight than anywhere else on Earth, all year long. The ocean there soaks up that heat and holds it. When the surface across this particular stretch warms even slightly above its normal, it warms the air sitting on top of it, and that air begins to rise. Rising air over a warm ocean is the seed of weather, and this is the most closely watched patch of warm ocean on the planet. Why this exact rectangle, and not the water next door? The answer is that forecasters learned, over many decades of records, that the temperature here tracks the whole pattern better than anywhere else. It is the spot where the ocean and the atmosphere talk to each other most clearly. Watch this one region, and you can read the state of the entire dance. That is why it earned its role as the official gauge. The way this water behaves normally is the key to understanding El Niño. In an ordinary year, steady winds blow along the equator from the Americas toward Asia. Those winds drag the warm surface water westward, piling it up near Indonesia and the western Pacific. The eastern side, off South America, is left cooler, because deep cold water rises to replace what the winds pushed away. The warm pool sits in the west, and the cool water sits in the east. That is the resting state. El Niño is what happens when that arrangement breaks down. The winds slacken, the warm water is no longer held in the west, and it slides back toward the centre and the east. The rectangle we watch, sitting in the middle of it all, warms up. When it crosses the mark and stays there, the season has turned. So the temperature in this stretch is really a readout of a much larger shift in where the ocean's warmth is sitting. The distance from this water to the United States is enormous, and that distance is exactly the point worth holding on to. The warm rectangle is farther from most of the country than one edge of the globe is from the other in some directions, and yet its state changes the odds for a snowy winter in the north and a wet one in the south. The connection is not magic. It runs through the air, along paths that carry the ocean's influence step by step across the map. Those paths have a name in the science. Forecasters call them teleconnections, which is just a long word for a link between weather in one place and weather far away. A warm rectangle on the equator lifts air, that lifting shifts the winds high above, and the shifted winds steer storms towards some regions and away from others. The word sounds technical. The idea is simple. Pull on one end of the system, and the far end moves. This is why a temperature taken from empty ocean can headline a forecast for the whole country. The rectangle is not important for itself. It is important because it is the throttle. Nudge the warmth there, and the pressure travels outward through the atmosphere until it reaches places with names and streets and rooftops. By June, that throttle had been pushed forward and was holding. The water in the watched rectangle was warm and climbing, and the atmosphere had begun to answer. The next step in the story is how forecasters saw this coming before it fully arrived, in the quiet signals of spring, when the ocean was already turning under the surface. The advisory in June was the headline. The story under it began weeks earlier, in signs that most people never see. Forecasters do not wait for the surface to warm before they suspect an El Niño. They watch the ocean below the surface and they watch the winds, and both were talking well before the official call. The first clue lay underwater. Below the visible surface of the tropical Pacific at depth sits a reservoir of warm water that shifts around long before the top does. In the early spring of 2026, forecasters saw a large pool of this warmer-than-normal water spread eastward beneath the surface, along the equator. Warm water at depth is like money in the bank. It does not spend itself all at once, but it is ready to rise and warm the surface when the winds allow. The second clue was in the wind. The steady trade winds that normally push west along the equator had begun to weaken, and in places they briefly turned the other way. When those winds relax, they stop holding the warm water in the western Pacific. The warmth is free to slide back east. Weakening trades in spring are one of the classic early fingerprints of an El Niño taking shape, and they were there. Put those two together, warm water waiting below, and winds no longer holding it west, and you have the makings of a turn. Through March, April, and May, the surface followed. The season-long average for the watched rectangle climbed from just barely above normal to clearly warm. Week by week, the readings pushed higher. What began as a hint underwater surfaced as a trend anyone tracking the numbers could see. This did not come out of a calm ocean. It came out of a cool one. The winter before had been shaped by La Niña, the cool phase, when the eastern Pacific runs colder than normal. So the spring of 2026 was a handoff, cool giving way to warm. The ocean passed through a brief neutral middle, where it sat near its average, and then kept going into warm territory. A full swing from one phase toward the other in a single season is quick, and forecasters flag the pace. The speed mattered for a practical reason. When a change moves fast and lines up across several signals at once, forecasters gain confidence. It was not one lonely warm reading. It was warm water below, slack winds above, and a rising surface all pointing the same way. Agreement across independent signals is what turns a hunch into a forecast, and by late spring the signals agreed. Still, the people making the call stayed careful, and the reason is honest. Spring is the hardest time of the year to forecast this pattern. The ocean and the atmosphere are loosely coupled then, and small wobbles can grow or fade. Forecasters know this well enough to name it, and they leaned on the physical signs, the warm subsurface water and the wind shifts, rather than on any single month's number. Those physical signs are what gave them the nerve to move toward an advisory as spring closed. It is worth picturing the scale of what they were tracking. The warm pool spreading east under the surface was not a local patch. It stretched across a huge length of the equatorial Pacific, a slab of warmed water moving slowly toward the surface over weeks. Nothing about it was sudden in human terms. It was the ocean turning over, ponderous and steady, the way something enormous changes direction. Forecasters were watching a very large, very slow shift gather itself. By the time the surface caught up, the outcome was no longer in much doubt. The subsurface heat had risen, the trades had stayed weak, and the watched rectangle had crossed and held past the mark. The spring signals had delivered exactly what they promised. What had been a set of early fingerprints in March became a declared El Niño by June. So the announcement was really the ocean finishing a move it had started months before, in quiet ways, under the surface and in the winds. Knowing the signs is one thing. Knowing why they add up to a pattern that reaches America is another. That is the machinery itself, the plain mechanics of how El Niño runs, and it is where the story turns next. To follow the rest of this story, it helps to understand the engine. El Niño is not a storm or a front. It is a shift in a balance, a change in the way the tropical Pacific and the air above it hold each other. Once you see the balance and how it tips, the rest of the pattern falls into place. Start with the normal state, the one El Niño interrupts. Along the equator, the trade winds blow steadily from east to west, from the Americas toward Asia. They have blown that way on average for as long as there have been records. Those winds do real work on the ocean. They drag the warm surface water westward across the whole width of the Pacific, hour after hour, year after year. That dragging piles warm water up in the west. Near Indonesia and the western Pacific, the sea sits higher and warmer, a great pool of heat held in place by the wind. Over on the eastern side, off South America, the surface is pulled away, and colder water rises from the deep to fill the gap. So the resting Pacific is lopsided by design. Warm and high in the west, cool and low in the east, with the winds holding the tilt. El Niño begins when the winds ease. For reasons that involve the slow rhythms of the ocean and the atmosphere, the trades weaken, sometimes only a little, sometimes enough to reverse in spots. The moment they relax, the force holding the warm pool in the west lets go. Water, like anything piled up and released, moves back toward level. The warm surface slides eastward across the equator, toward the center of the ocean and beyond. As that warm water spreads east, it carries its heat with it into the watched rectangle and the waters past it. The eastern Pacific, normally cool, warms up. The upwelling of cold water from below slows down, because the winds that drove it have faded. Warmth that used to be bottled up in one corner is now smeared across a much wider stretch. That redistribution of heat is the physical core of El Niño. Nothing is created. The ocean's warmth simply moves to a new address. Here is the part that makes it hold together. The winds and the water are not two separate things. They push on each other. Weaker winds let the warm water move east, and the warmer eastern water then weakens the winds further, because winds partly blow in response to differences in ocean temperature. Ease the difference, and you ease the winds. So a small nudge can feed on itself. The ocean and the sky reinforce the same change, and the pattern locks in for a season or more. That self-reinforcing loop is why El Niño is not a passing blip. Once the warm water and the slack winds start backing each other up, the pattern tends to strengthen and last. It is also why forecasters can see it coming. A system that reinforces itself moves in a direction long enough to be spotted early and tracked. The same feedback that makes El Niño powerful also makes it, to a degree, predictable. If a comparison helps, think of a shallow pan of water tilted and held at an angle, with the water heaped up on the low end. That heap is the warm pool in the west, and your steady hand is the trade winds. Let the pan settle back toward level, and the water sloshes to the middle and the other side. El Niño is the Pacific sloshing back when the wind's grip loosens, only far slower and across a basin that spans a third of the globe. By the summer of 2026, the pan had begun to settle. The trades had weakened, the warm water had slid east, the eastern Pacific had warmed, and the loop between wind and water was turning in El Niño's favour. The engine was running, and it was running towards strength rather than away from it. An engine, though, is only the start. The heat now spread across the eastern Pacific has to reach the sky before it can reach America. That handoff, from a warm ocean surface to the moving air above it, is the next link in the chain, and it is where the story goes now. A warm ocean does not steer weather by itself. It has to hand its heat to the air. That handoff is the hinge of the whole pattern, the moment the ocean's slow warmth becomes the atmosphere's fast motion, and it happens through a process anyone who has watched a summer sky already knows. Warm water heats the air just above it. Warm air is lighter than the air around it, so it rises. As it climbs, it cools, and the moisture it carried begins to condense into clouds. Keep that going over a wide, warm ocean, and the clouds build into tall towers of thunderstorms. This is the same lifting that makes an afternoon storm on a hot day, only spread across an enormous stretch of tropical sea and running day after day. In a normal year, that heavy lifting happens mostly in the west, over the warm pool near Indonesia. That is where the ocean is warmest, so that is where the air rises and the biggest tropical thunderstorms cluster. When El Niño moves the warm water eastward, it moves the storms with it. The zone of rising air and towering clouds shifts from the far western Pacific toward the center of the ocean. The address of the world's most active tropical weather changes. That shift is small on a globe and huge in its consequences. The tropics are the furnace room of the atmosphere. The rising air over those thunderstorms has to go somewhere once it reaches the top. It spreads out high above, then sinks back down thousands of miles away and returns along the surface. This great overturning loop is one of the main ways the atmosphere moves heat around the planet. Move the furnace, and you move the whole loop with it. When the rising branch slides east during El Niño, the sinking branches move too. Air that used to descend over one region now descends over another. Sinking air tends to be dry and calm, so it suppresses rain where it lands. Rising air tends to be wet and stormy. So relocating the tropical thunderstorms quietly rewrites which distant regions get more rain and which get less. The ocean warmed, the storms moved, and the map of wet and dry began to change with them. There is a second effect, and it reaches even higher. The tall thunderstorms pump heat and air up to the level where the fast, high-altitude winds run. Where all that air piles up aloft, it bulges outward and pushes on those winds. This is how a change at the ocean surface reaches the top of the weather layer. The storms are the elevator. They carry the ocean's message from the sea to the level where continents' weather is steered. It is worth being clear about the chain, because it is the spine of everything that follows. Warm water heats the air. The air rises into thunderstorms. The thunderstorms shift east with the warm water. That shift moves the great overturning loops and pushes on the high winds. Each link is ordinary on its own. Strung together across an ocean, they turn a mild change in sea temperature into a force felt on other continents. None of this is fast in the way a passing storm is fast. The handoff runs continuously through a season, a steady transfer of heat from a warm ocean to a busy atmosphere. Any single day might look unremarkable out there, a stretch of showers over open water. The power is in the sum, the same process repeating for months over a vast area, leaning on the atmosphere without pause. By midsummer of 2026, that lean was underway. The warm eastern Pacific was feeding taller storms farther east than usual. The overturning loops were shifting, and the high winds were beginning to feel the push. The ocean had handed its heat to the sky, and the sky had started to move. The next question is where that push goes once it reaches the high winds. For the United States, one high-altitude wind matters more than any other. It is the current that carries storms across the country, and El Niño moves it. That current, and where it goes, is the next piece of the story. For weather in the United States, one ribbon of wind matters more than the rest. It runs high above the ground from west to east, and it acts as a track for storms. Forecasters call it the jet stream. Where it goes, storms tend to follow, and El Niño has a habit of moving it. The jet stream is a fast river of air near the top of where weather happens, miles above the surface. It forms along the boundary between colder air to the north and warmer air to the south. Storms ride along it the way a leaf rides a current. When the jet dips south over a region, that region tends to get the storms and the cooler, wetter weather. When the jet lifts north or goes quiet, a region is often left milder and drier. There is more than one branch of this current over North America. The one that matters most for an El Niño winter is the southern branch, sometimes called the subtropical jet. It runs at lower latitudes across the southern part of the country. In many years it is weak and unremarkable. In an El Niño year, it wakes up. Here is how the ocean reaches it. Remember the tropical thunderstorms that shifted east with the warm water. All that rising air spills out at high altitude and strengthens the winds aloft over the Pacific. That extra push feeds the southern branch of the jet stream and pulls it into a straighter, stronger, more southern path. El Niño does not invent the jet stream. It energizes one branch of it and moves it toward the south. A strengthened southern jet becomes a delivery route. It runs from the Pacific, across the southern tier of the United States and off toward the Atlantic. Storms that form or pass along it get carried straight across the southern states. That is the physical reason an El Niño winter tends to be wetter across the south. The track that carries storms has been pulled down over those states and switched on. The same move that wets the south tends to dry the north. When the storm track sets up across the southern part of the country, the northern part is often left on the mild, quiet side of the pattern. Storms that might have crossed the northern states in another year ride the southern route instead. So the north frequently sees a warmer, drier stretch. Not because storms vanish, but because their usual highway shifted south. This is the clearest way to picture El Niño's grip on American weather. Think of the jet stream as a hose laid across the country, and El Niño as a hand that pulls the hose southward and turns up the pressure. The southern states stand in the spray. The northern states stand off to the side, drier and milder. The water did not change. The aim of the hose did. It is worth stressing that this is a tilt in the odds, not a guarantee for any single day. The jet stream wanders on its own from week to week, and plenty of other forces tug at it. What El Niño does is make the southern, wetter setup more common across the season than it would otherwise be. Over 3 winter months, those small daily nudges add up into the pattern the outlooks describe. The strength of the tilt tends to track the strength of the event. A stronger El Niño, with warmer water and busier tropical storms, pushes harder on the southern jet and makes its influence more likely to show. That is one more reason the climb in ocean temperature through the summer of 2026 mattered. A stronger event was leaning on the very current that steers America's winter. By its nature, though, this whole picture points to winter. The jet stream's El Niño behavior is strongest in the cold season, when the temperature contrasts that drive it are sharpest. That is why the summer of the announcement was calm and the winter ahead was the main event. Before we reach that winter, though, there is a fair question about trust. Spring forecasts of this pattern are famously shaky, and it is worth understanding why this one earned confidence. That is the next piece. Every forecast comes with a question of trust, and El Niño forecasts made in spring come with more than most. There is a well-known weak spot in the year, a stretch when predictions of this pattern are least reliable. Forecasters have a name for it, and understanding it explains why the June call carried the weight it did. The weak spot is spring. In the months around April and May, forecasts of the tropical Pacific tend to go wrong more often than at any other time. The reason is a loosening of the very connection that makes El Niño predictable. For much of the year, the ocean and the atmosphere hold each other tightly, and that grip lets forecasters project the pattern forward. In spring, the grip slackens. The two drift a little, and small random wobbles can push the season in either direction. Because of that slack, A warm reading taken in spring is harder to trust than the same reading taken in fall. The ocean might be nudging toward El Niño, or it might be passing through a spell that fades by summer. Forecasters know this, and they hedge accordingly. When they speak carefully in spring, using words like favoured and likely rather than certain, they are not being coy. They are respecting a real limit in what the season allows them to see. This is why the outlooks earlier in 2026 were full of caution. Through the late winter and into spring, the official language leaned on probabilities rather than declarations. There was a chance of El Niño growing over time, but the spring weak spot sat squarely in the way. Anyone reading those outlooks would have seen confidence rising slowly, held back on purpose until the calendar cleared the shaky stretch. By June, the calendar had cleared it. As spring gave way to summer, the ocean and the atmosphere tightened their grip again, and the signals steadied. The warm water was not fading. The slack trade winds were holding. The surface temperature in the watched rectangle had crossed the mark and stayed there through the hardest months to read. Surviving the weak spot is itself a kind of proof. A pattern that holds through spring's noise is usually a pattern that means it. That is the quiet logic behind the timing of the advisory. Forecasters could have hinted louder in April. They chose to wait until the signal had come through the least trustworthy part of the year intact. When they finally moved from watch to advisory in June, they were standing on firmer ground, past the point where a spring fluke could still be fooling them. The delay was not doubt, it was discipline. There is a second reason confidence firmed as summer came, and it lives below the surface. The large pool of warm water at depth, the reservoir noted back in spring, does not lie. Subsurface heat changes more slowly and fools forecasters less often than the fickle surface. That deep warmth was substantial and spread out along the equator, and it was feeding the surface from below. A well-stocked reservoir of warm water under the Pacific is one of the steadiest hints that an El Niño will not only form but last. The models agreed, and their agreement mattered too. Forecasters run many computer simulations of the ocean and atmosphere, built by different groups in different ways. When those independent models scatter, confidence is low. When they line up, confidence climbs. Through the late spring and early summer, they lined up, pointing together toward a strengthening El Niño through the fall and winter. Broad agreement across independent models is one of the firmer foundations a seasonal forecast can have. So the confidence in this event did not rest on one bright reading. It rested on a pattern that cleared the year's hardest test, a deep reservoir of warmth that resists fooling, and a fleet of models rowing the same direction. Each of those alone would be suggestive. Together, past the spring weak spot, they were enough to say the word. Understanding that trust is worth the effort, because the rest of this report leans on the forecast holding. An El Niño confirmed in June, past the shaky season and still building, is a solid thing to reason from. Before following it into fall and winter, though, it is worth stepping back to where the name itself came from, and to the people who first understood that a warm ocean and a shifting sky were one story. That history is next. The name is old, older than the science. Long before anyone measured the tropical Pacific or ran a model, fishermen along the coast of South America had noticed something and given it a name. That name is the one the whole world uses today, and the story behind it is worth knowing. The fishermen work the waters off Peru and Ecuador, where the sea is normally cool and rich with fish. Most years the cold current held and the fishing was good, but every so often, around the end of the year, the water turned warm and the fish grew scarce. Because the warming tended to arrive near Christmas, the fishermen named it after the Christ child. El Niño, in Spanish, means the boy child. The name marked a season, not a science. For a long time that was all it was, a local quirk of the Peruvian coast, a warm spell that came now and then and spoiled the catch. Nobody connected it to weather on the other side of the world. The warm water off South America and the strange rains and droughts in far-off places looked like separate puzzles, unrelated to each other. The link that would join them had not been found yet. The first half of the answer came from a scientist studying the atmosphere, not the ocean. In the early 20th century, an English mathematician named Gilbert Walker was working in India, trying to forecast the monsoon rains that the country depended on. Sifting through mountains of weather records, he found a seesaw in the air pressure across the tropical Pacific. When pressure rose on one side of the ocean, it fell on the other, back and forth over the years. He called this seesaw the Southern Oscillation. Walker had found a real and large pattern in the atmosphere, but he could not fully explain it. He saw that the pressure seesaw was tied to droughts and floods across a wide sweep of the globe, from Australia to India and beyond. What he did not have was the reason. He was looking at half the picture, the atmospheric half, without the ocean piece that drove it. The seesaw was real. Its engine was still hidden. The other half came decades later, from a Norwegian scientist working in the United States. In the late 1960s, Jacob Bjerknes put the two pieces together. He realized that Walker's pressure seesaw in the air and the warm and cool swings of the Pacific Ocean were not two patterns, they were one. The ocean and the atmosphere were pushing on each other, warm water changing the winds and winds changing the water, in the very feedback loop described earlier in this report. That insight was the birth of the modern understanding. Bjerknes showed that El Niño, the warm ocean off South America, and the southern oscillation, the pressure seesaw in the sky, were the ocean and atmosphere halves of a single coupled system. Scientists eventually joined the two names into one term for the whole cycle, honouring both the fisherman's warm water and Walker's atmospheric seesaw. The local Christmas curiosity had become a planet-scale phenomenon with a unified name. Once the system was understood as coupled, prediction became possible. If the ocean and the air moved together, then watching one could reveal the other, and the deep reservoirs of warm water could hint at what the surface would do months ahead. The buoys strung across the equator, the satellites, and the models all grew out of that single realization. Everything in this report traces back to the moment someone saw that the warm sea and the shifting winds were one thing. It is a fitting history for a pattern that links distant places. It took a Peruvian fishing tradition, an English mathematician in India, and a Norwegian scientist in America to assemble the full picture, each holding a piece the others lacked. The name still carries that long journey, from a warm current at Christmas to the throttle on America's coming winter. With the name and the science in hand, the event of 2026 stands in a long line of others. To judge how big this one might become, it helps to set it beside the El Niños that came before, especially the last one and the giants of the record. That comparison is next. To size up any El Niño, forecasters look backward. The pattern has repeated for as long as there are records, and each event leaves a mark. Setting the 2026 event beside its predecessors is the clearest way to sense what it might do and where it might rank. Start with the most recent one because it is freshest. An El Niño formed a few years back, in 2023, and ran into 2024. It reached a strong level, though not the very top tier, and it left a clear fingerprint on the globe. That event helped push world temperatures to record highs, and it delivered the kind of wetter, southern winter across the United States that El Niño tends to favour. It was a full-sized event, and it is close enough in time to serve as a living reference. Above that recent event sit the giants. The strongest El Niños on record reached what forecasters call the super level, where the watched ocean runs around 3.5 degrees Fahrenheit above normal or more sustained through the winter. There have only been a handful of those in the modern record. Two stand out. One peaked in the winter of 1997 into 1998. The other peaked in the winter of 2015 into 2016. Both reshaped a full season of weather across much of the planet. Those two super events are the yardsticks for the extreme end. The one in the late 1990s brought heavy rains and flooding to California and the southern states, and stands as one of the most powerful on record. The one a decade ago helped drive global temperatures to what were, at the time, the highest ever measured. When forecasters talk about how large the 2026 event could grow, these are the benchmarks they have in mind. So where does the new event fit? By the summer of its arrival, it had already climbed past the weak range and was still rising, with the outlook calling for it to reach at least strong, and with a real chance of pushing toward the super tier by winter. That places it, at a minimum, in the company of the recent full-sized event, and possibly among the giants. It is not a marginal, barely there El Niño. It is shaping up as a major one. The comparison is useful for another reason. It shows that a strong El Niño is not a freak or a first. The country has been through events like this before and come out the other side, and the record of past events is exactly what lets forecasters set expectations without guessing. When they say a strong El Niño tends to bring a wetter south and a milder north, they are reading from a stack of previous winters that behaved that way. Forecasters lean on that stack in a specific way. They pick out past years whose conditions most resemble the current one, and they study how those years unfolded. These are called analog years, and the ones chosen for 2026 include several past El Niños stretching back decades. Looking at how those seasons played out gives a grounded sense of the range of outcomes this year might hold, based on real weather that really happened. There is a limit to the comparison, and honesty requires naming it. No two El Niños are identical. They differ in exactly where the warmest water sits, in how strong they grow, in how the rest of the atmosphere is arranged around them. So the past is a guide, not a script. A season that resembles 1997 in the ocean can still diverge in the details of who gets the heaviest rain. The analogues narrow the range. They do not fix the answer. Still, the weight of history points one way. A strong and strengthening El Niño, matched against the record, tends to leave a real mark on American weather, most of it in the winter, most of it in the tilt toward a wetter south and a milder north. The 2026 event is arriving with the size to do that, and possibly with the size to do it firmly. One mark shows up before winter even begins, and it is global rather than regional. A strong El Niño tends to nudge the temperature of the entire planet upward. That effect, and the delay built into it, is the next piece of the story. Before El Niño reshapes any single country's winter, it does something to the whole planet at once. It nudges the average temperature of the entire Earth upward. This is one of the most dependable effects in the whole pattern, and it is worth understanding on its own, because it sets the backdrop for everything else. The reason is heat, and where that heat goes. During El Niño, the tropical Pacific spreads its warmth across a much wider area of ocean surface than usual. A larger warm surface means more heat passing from the sea into the air. On top of that, the shift in the pattern leaves broad regions under sinking cloud-free air, where sunshine pours down and warms the ground with nothing to block it. Warm ocean releasing heat, plus clear skies letting sun through, adds up to a warmer world overall. History makes the effect plain. The strong El Niño of a decade ago helped drive global temperatures to record highs in its years. The recent event a few years back did the same, lifting the planet's average to new records. When forecasters look at the long temperature record, the warmest years cluster around strong El Niños. The pattern hands the globe a temporary boost, laid on top of whatever the longer trend is already doing. There is a delay built into this, and the delay matters. El Niño's peak in the ocean tends to come in winter, but its peak effect on global temperature usually arrives months later, often the following year. The ocean has to warm the atmosphere, and the atmosphere takes time to respond across the whole planet. So the temperature bump from an El Niño lags behind the ocean event that causes it. The warmest stretch often comes as the El Niño itself is already fading. That lag explains a pattern in the recent record. The cool phase that preceded this El Niño, the La Niña of the last couple of years, had held global temperatures down a little, the way the cool phase tends to. Even so, the most recent year still landed as the third warmest ever measured, behind the 2 years shaped by the previous El Niño. The cool phase trimmed the top off, and the year was still near the record. That tells you how warm the baseline has become. Now the cool phase is gone and the warm phase has taken over. With a strong El Niño building through the second half of 2026, the setup points toward another push at the temperature records, most likely showing up in full force the following year once the lag has run its course. Forecasters treat a fresh temperature record in the wake of a strong El Niño as one of the more likely outcomes on the board, though the exact ranking will not be known until the numbers are in. It is worth being careful about what this does and does not mean for a person's daily life. A rise in the global average of a fraction of a degree is not something anyone feels on a given afternoon. It is a statement about the whole planet, ocean and land, poles and tropics, averaged together over a year. The number is small, and the reach is total. It shifts the odds of heat waves and warm spells across many regions at once, without dictating any single day anywhere. The global bump also sits on top of a longer climb. The planet has been warming over the decades for reasons separate from El Niño, and the pattern rides on that rising baseline. So each strong El Niño now tends to set its records a little higher than the last, not because the pattern itself is stronger, but because it is stacking its temporary boost on a warmer starting point. The cycle is old. The floor it starts from keeps inching up. For the United States, this global warmth is the wide backdrop against which the regional story plays out. A warmer world tilts the odds toward hot spells and mild winters even before the jet stream's local effects are counted. It is the low, steady pressure under everything else El Niño does. That regional story has two faces, and one of them is about what does not happen. A strong El Niño tends to quiet the Atlantic hurricane season, holding storms down when they would otherwise form. Why a warm Pacific calms the Atlantic is the next piece of the story. Some of El Niño's biggest effects are things that do not happen. The clearest example sits in the Atlantic Ocean, where a strong El Niño tends to hold the hurricane season down. It is one of the most reliable long-distance links in the whole pattern, and it works through a force with a plain name. That force is wind shear. Wind shear is simply a change in the wind with height, when the wind blows one way near the surface and a different way, or much faster, higher up. Hurricanes hate it. A young storm needs to stack its thunderstorms neatly on top of each other to organize and strengthen. Strong wind shear leans on that stack and tears it apart, blowing the top of the storm one way while the bottom goes another. Where shear is high, hurricanes struggle to form and struggle to grow. El Niño raises the shear over the Atlantic, and the path from one ocean to the other runs back through the tropical Pacific. Recall the tropical thunderstorms that shift eastward with the warm water. All that rising air spills out at high altitude and speeds up the winds aloft. Those faster high-level winds spread outward and reach across Central America into the Atlantic, where they blow over the top of the region's developing storms. The Pacific gets busier overhead, and the Atlantic gets windier aloft as a result. So the chain is this. A warm Pacific builds taller storms, those storms strengthen the high winds, and those high winds ride east and shear the tops off Atlantic systems before they can mature. The warm water sits an ocean away from the Caribbean and the Gulf, yet its fingerprint lands squarely on them. It is one more case of the pattern reaching far past where it lives. The record backs this up. When forecasters line up past El Niño years, the Atlantic hurricane seasons in those years lean quiet more often than not. The strong events especially tend to suppress the number of storms and, importantly, the number that grow into major hurricanes. The link is not perfect, but it is strong enough that forecasters lean on it heavily when they build the seasonal outlook. A developing El Niño is one of the main reasons a season gets called below normal before it even begins. There is a useful way to picture it. Imagine trying to build a tall, narrow tower of blocks in a steady crosswind. Without the wind, the tower stands. With it, the tower topples before it gets high. Wind shear is that crosswind for a hurricane, and El Niño turns the crosswind up across the Atlantic. Storms that might have towered in a calm year get knocked down while they are still small. It is important to hold the honest limit alongside the pattern. A quieter season is a lower count and a lower chance of big storms, not a guarantee of safety. Wind shear tilts the whole basin toward fewer and weaker storms, but it does not seal the ocean. A storm can still slip through, especially close to the coast, where systems sometimes form quickly in warm near-shore water before the shear can act on them. The pattern lowers the odds. It does not remove the risk. That distinction is the one forecasters repeat every single season, and it holds this year. It only takes one storm reaching land to make a quiet season feel anything but quiet for the people in its path. A below-normal outlook is a statement about the whole basin over the whole season. It says nothing about whether your particular stretch of coast gets a landfall. Those are two different questions, and the second one is decided storm by storm, not by the seasonal tilt. Still, the tilt is real and it is meaningful, and by the summer of 2026 it was already shaping the year's forecast. A strengthening El Niño was raising the shear over the Atlantic, and the season's outlook reflected it, leaning below normal for the number of storms expected. What that outlook actually said, in numbers, and how to weigh it honestly, is where the story turns as this first half closes and the next begins. The season's forecast arrived before the season did. In late May, ahead of the official start of the Atlantic hurricane year, the country's forecasters released their outlook for the months ahead. The headline was a quiet one. They expected a below-normal season, and the reason they gave, first and foremost, was the developing El Niño. The numbers put shape on that word. A normal Atlantic season, measured against the long-term average, runs about 14 named storms. Of those, roughly 7 become hurricanes, and about 3 grow into major hurricanes, the strongest category. Those figures are the baseline, the middle of the road, the yardstick every season gets measured against. Against that yardstick, the outlook for 2026 sat low. Forecasters called for something in the range of 8 to 14 named storms. Of those, they expected 3 to 6 to reach hurricane strength, and only 1 to 3 to become major hurricanes. Every part of that forecast leaned toward the low end of normal or below it. The season was being set up to run quiet. The outlook also came with odds attached, and the odds tell the story cleanly. Forecasters put the chance of a below normal season at better than half, the chance of a near normal season at about a third, and the chance of an above normal season at only about 1 in 10. When the most likely single outcome is a quiet year, and the least likely is a busy one, the pattern behind it is doing real work. That pattern was El Niño. An independent forecast from a university team, released a few weeks later, pointed the same way and leaned even lower. That group expected roughly 11 named storms, about 5 hurricanes, and 2 major hurricanes, which would put the season near 40% below the long-term average. When 2 separate forecasts built by different people using different methods land in the same low territory, confidence in the quiet outlook goes up. They were reading the same El Niño and reaching the same conclusion. The reasoning under both forecasts was the wind shear described earlier. A strengthening El Niño raises the high-level winds over the Atlantic, and those winds tear at storms before they can organise. On top of that, forecasters noted the broader setup favoured sinking, stable air over parts of the tropical Atlantic, which further discourages storms from forming. The ingredients for an active season were being held back by the pattern out in the Pacific. Forecasters also lean on history when they build these outlooks. They picked out past years whose conditions resembled this one, several earlier El Niño seasons stretching back decades, and studied how those years turned out. Nearly all of them ran below average in the Atlantic. That agreement across analogue years is part of why the confidence in a quiet season was as firm as it was. The past cases and the current signals told the same story. Now comes the part that forecasters repeat every year, and it is the most important line in the whole outlook. A quiet season is not a safe season. The number of storms expected across the entire basin says nothing about whether any one of them reaches your coast. A below normal year can still produce a damaging landfall, and history is full of quiet seasons that delivered one bad storm to one unlucky place. The count and the risk to a given town are 2 different things. That is why the people issuing the outlook paired every low number with a plain warning to prepare anyway. They urged coastal residents to review their plans before a storm ever threatened, not after. The logic is simple. Preparation takes the same effort whether the season ends up busy or quiet, and it only has to matter once. A single storm in a slow year can undo the comfort of a low forecast in an afternoon. So the Atlantic outlook for 2026 reads as a genuine tilt toward calm, driven by El Niño, held up by 2 independent forecasts and a stack of past seasons, and wrapped in an honest caveat. Fewer storms are likely, 0 storms are not promised. The pattern lowered the count and left the individual risk to be settled one system at a time. The Atlantic is only half of the picture, though. The same El Niño that quiets one ocean tends to stir another. While the Atlantic leans calm, the Pacific side of the country and the waters near the Gulf carry their own story, and that flip side is where the report turns next. El Niño does not calm every ocean. The same pattern that quiets the Atlantic tends to do the opposite on the Pacific side, and it leaves a few openings even in the basin it suppresses. The full picture of the storm season has 2 faces, and this is the busier one. Start with the Pacific. The wind shear that tears at Atlantic storms is the product of thunderstorms firing over the warm eastern Pacific. Right where those storms are firing, conditions turn favourable for tropical systems rather than hostile to them. The warm water and rising air that spell trouble for the Atlantic are fuel for the Pacific. So while forecasters expected a quiet Atlantic in 2026, they expected the eastern and central Pacific basins to run active. That flip is a standard feature of El Niño years, and it matters to real places. An active eastern Pacific season raises the odds for storms off the west coast of Mexico, and the risk of heavy rain and surf reaching the southwestern United States and Hawaii. The central Pacific, the stretch around the Hawaiian Islands, tends to see more activity too. The warmth that shelters the Atlantic coast leaves the Pacific side more exposed. One ocean's quiet is the other's busy season. Even the Atlantic is not sealed shut, and this is the second face worth understanding. A below-normal outlook lowers the count across the open ocean, where distant storms cross the tropical Atlantic and where El Niño's shear does its heaviest work. Closer to the American coast, the pattern has less grip. Storms that form near home, in the warm waters of the Gulf and just off the southeast, can still spin up before the shear reaches them. Forecasters have a plain name for those. They call them homegrown storms, systems that develop close to the coast rather than marching in from far away. These tend to form in the warm near-shore water, especially in the first half of the season, before the season's peak and before El Niño's shear is at its strongest. A homegrown storm has a short trip to land, sometimes only a day or two, which gives less warning and less time to prepare. That is the honest wrinkle in a quiet forecast. The storms El Niño suppresses best are the long-track ocean crossers, the ones that spend days over open water where the shear can tear them apart. The storms it suppresses least are the ones that pop up near the coast and come ashore quickly. So a below-normal season can still deliver a landfall from a storm that never spent much time on the open sea. The basin-wide calm and the coastal risk live side by side. History shows this clearly. There are quiet El Niño seasons on record whose single most damaging storm was a homegrown system that formed in the Gulf and struck within a couple of days. The low seasonal count offered no protection to the place it hit. That is the exact scenario forecasters have in mind when they tell people in a below-normal year to prepare as if it were any other. The seasonal number is a poor guide to any single coastline. There is also the plain fact that storms get named in order, regardless of how many arrive. The first names on the 2026 list begin with Arthur, then Bertha, then Cristobal, and continue down a set list. Even a quiet season works through the top of that list. A handful of named storms is not zero storms, and each one is a system somebody has to watch. The forecast lowers the total, it does not empty the map. So the storm season of an El Niño year is really two seasons running at once. The Atlantic leans quiet thanks to shear from the Pacific, but keeps a coastal door open for homegrown systems. The Pacific side leans active, with more risk for Mexico, the Southwest and Hawaii. The same warm water drives both, calming one ocean and stirring the other, and leaving no coast entirely off the hook. All of this belongs to the warm months though, when tropical storms are the main event. El Niño's deepest and broadest grip on American weather comes later, in the cold season, when the pattern reaches beyond the coasts and into the daily weather of the whole country. Why winter is the main act is the next piece of the story. Everything so far has pointed toward one season. El Niño arrives in summer and stirs the storm season, but its firmest, widest grip on American weather comes in winter. The cold months are the main act, and it is worth understanding why the pattern waits until then to show its full hand. The reason lives in the jet stream. Recall that the jet stream forms along the boundary between cold air to the north and warm air to the south, and that El Niño works by strengthening and shifting one branch of it. In winter, the contrast between cold northern air and warm southern air is at its sharpest. A sharper contrast makes a stronger, steadier jet stream, so the very current El Niño axon is at its most powerful exactly when winter arrives. A stronger jet stream is a more effective delivery system. In summer, the southern branch of the jet is weak and wandering, and El Niño's push on it produces little that a person would notice. In winter, that branch is muscular and well-defined, and El Niño's push lines it up into a persistent southern track across the country. The same nudge that did little in July starts steering storm after storm in January. The tool El Niño uses only becomes sharp in the cold season. There is a second reason winter matters more, and it is about what is at stake. Winter weather in the United States carries the country's heaviest hitters. Snowstorms, ice storms, cold outbreaks, and the long stretches of rain that fill reservoirs and swell rivers all belong to the cold season. When El Niño tilts the winter pattern, it tilts the season that holds the most consequential weather. A shifted summer is mild by comparison. A shifted winter reshapes the year. The effect also shows up more clearly in winter because the pattern is steadier then. Summer weather in America is ruled by local heat and afternoon storms, small scale and hard to tie to any distant cause. Winter weather is ruled more by the large-scale flow, the position of the jet stream, and the tracks of big storm systems. That large-scale flow is exactly what El Niño reaches, so its signal, faint against the noise of summer, stands out against the more orderly backdrop of winter. This is why the summer of the announcement felt so ordinary on the ground. El Niño was present and strengthening. The ocean was warm and climbing, and yet the daily weather across most of the country carried on much as it would have anyway. The pattern was loading its influence into a season that had not arrived yet. The quiet of that summer was not a sign of weakness. It was a sign that the main event was still ahead. The historical record makes the winter emphasis plain. When forecasters study past El Niños, the strongest and most consistent effects on American weather show up in the winter months, roughly from December through February. That is when the wetter south and the milder north appear most reliably in the record. Earlier and later in the year, the fingerprint fades. The heart of El Niño's influence beats in the cold season. The strength of the event feeds directly into this. A stronger El Niño, with warmer water and busier tropical thunderstorms, pushes harder on the winter jet stream and makes its winter effects more likely to appear. The climb in ocean temperature through the second half of 2026 mattered for precisely this reason. A strong event leaning on a strong winter jet is the setup most likely to produce a clear, wide fingerprint across the country. So the country spent the summer and fall watching a pattern gather force for a season still on the horizon. By the time winter arrived, the ocean was expected to be near its warmest, the jet stream near its strongest, and the two aligned to steer America's weather more firmly than at any other time of year. The stage was set for the main act. That act has two broad halves, split roughly by latitude. The southern part of the country tends to turn wetter and cooler, while the northern part tends to turn milder and drier. The southern half of that story, the wetter south, is where the report goes next. The clearest place to watch El Niño work on American weather is the southern tier of the country. From California across the southwest, through Texas, and along the Gulf to the southeast, an El Niño winter tends to run wetter than normal. That band of states stands directly in the path of the storm track El Niño builds, and the reason traces straight back to the jet stream. Recall the southern branch of the jet stream, the one El Niño strengthens and pulls south in winter. That branch runs from the Pacific, across the southern United States, and off toward the Atlantic. It carries storms along its length like rail cars on a track. When El Niño lights it up and anchors it over the southern states, those states become the route that Pacific storms travel. More storms crossing overhead means more rain and mountain snow spread across the season. California often sees the effect first, because it sits where the storm track comes ashore. In a strong El Niño winter, the parade of Pacific storms can bring heavy rain to the lowlands and deep snow to the mountains. The record holds vivid examples. The powerful El Niño of the late 1990s delivered soaking rains and flooding to California and much of the southern tier. When forecasters warn that a strong event could bring a wet, stormy winter to the state, they are reading from seasons like that one. The wetness carries eastward along the same track. The southwest, often parched, tends to pick up more rain and snow than usual, welcome moisture in a dry region. Texas leans wetter. The Gulf states and the southeast, including Florida, tend to see more rain and more cloud than a normal winter brings. The whole southern band shares in the pattern because they all lie under the same energized storm route. The temperature side of the southern story is quieter but real. Along the southern tier, from Texas through the southeast, El Niño winters tend to run near normal or a little cooler than average. The extra clouds and rain block some sunshine and hold daytime temperatures down, and the storm track can pull cooler air across the region. It is not a deep freeze. It is a lean toward grey, damp, and mild to cool, the weather of a busy storm track rather than a cold snap. That combination, wetter and a touch cooler, has real consequences for the people living under it. More rain across the south raises the risk of flooding, especially in low-lying and flood-prone areas and along rivers that fill through a wet winter. Saturated ground sheds new rain quickly, so a run of storms can turn a manageable amount of water into a hazard. The benefit of a wet winter, refilled reservoirs and eased drought, comes paired with the cost of high water in the wrong places. There is a plain way to picture the whole southern pattern. Think again of the jet stream as a hose pulled south and turned up, with the southern tier standing in the spray. California catches the first burst as the water comes ashore, and the rest of the band, from the southwest through Texas to Florida, stands downstream in the same wet path. The states change, but the water keeps coming along the route El Niño laid down. The strength of the event shapes how firmly this appears. A strong El Niño pushes the southern jet harder and makes the wet, stormy southern winter more likely to show up clearly. A weaker one leaves the pattern fainter and easier for other forces to override. With a strong event building through 2026, the odds favoured a wetter-than-normal winter across much of the southern tier, though the heaviest rain would fall where individual storms happen to track. That last point is the honest limit on the whole southern forecast. El Niño tilts the odds toward a wet season across the band, but it does not assign the rain city by city. Some places in the wet zone will end up soaked, others closer to normal, depending on where the storms line up week to week. The seasonal tilt is real. The local total is still written one storm at a time. While the south turns wet, the northern half of the country tends toward the opposite. The warmer, drier north is the mirror image of this story, and it is where the report goes next. The northern half of the country lives on the other side of El Niño's winter pattern. While the southern tier turns wet and cool, the northern tier tends to run warmer and drier than normal. From the Pacific Northwest across the northern plains to the Great Lakes and into the northeast, an El Niño winter often means a milder, quieter season, and the reason is the same jet stream that soaks the south. The link is direct. When El Niño pulls the storm track south across the country, it pulls it away from the north. The storms that ride the southern route are storms the northern states do not get. With the main highway shifted below them, the northern tier is left on the calm, mild side of the pattern, out of the parade. The north does not turn warm because heat is added. It turns warm because the cold, stormy weather is routed elsewhere. There is a second piece to the northern warmth. In many El Niño winters, the flow of air across the northern part of the continent discourages the deep pushes of Arctic cold that bring the harshest cold snaps. The bitter outbreaks that plunge temperatures far below normal become less frequent, or milder when they come. Fewer hard freezes and more mild stretches add up, over 3 months, to a winter that averages warmer than usual across the northern states. Alaska tends to share in this. Parts of Alaska often run warmer than normal in an El Niño winter, along with the northern tier of the lower states. It is one more sign that the warmth is tied to the large-scale flow, which reaches from the far northwest across the top of the continent. The whole northern rim of the country leans mild together, because they all sit on the same quiet side of the shifted pattern. The drier half of the northern story follows naturally. Fewer storms crossing the north means less rain, and, more to the point, less snow. Many northern cities in an El Niño winter see below normal snowfall, simply because the systems that would drop it are tracking to the south. For places that depend on winter snow, for their water supply or their winter economy, a mild El Niño winter can mean a lean one. The quiet has a cost as well as a comfort. It is worth being careful here, because a milder average does not mean a winter without cold or snow. The north still gets winter, cold snaps still arrive, and snowstorms still fall, sometimes big ones. El Niño shifts the odds toward a milder, drier season overall, but it does not switch winter off. A single strong storm can still bury a northern city, even in a season that ends up warm and dry on average. The tilt is in the season's total, not in any one week. The Great Lakes and the Ohio Valley sit in an interesting middle ground, and honesty means naming the uncertainty there. These regions lie near the boundary between the wet southern pattern and the dry northern one, and exactly where that boundary falls can vary from one El Niño to the next. A shift of a few hundred miles in the storm track decides whether a place like the Ohio Valley leans wet or dry. Forecasters watch that dividing line closely, because so many people live along it. The strength of the event shapes the northern pattern too, in the same way it shapes the southern one. A strong El Niño makes the mild, dry northern winter more likely to appear clearly, by pulling the storm track firmly south and keeping it there. With a strong event building through 2026, the odds favoured a warmer than normal, drier than normal winter across much of the northern tier, with the usual caveat that individual storms could still break the pattern for a week at a time. So the winter picture comes together as two mirror halves. The south stands in the storm track, wet and cool. The north stands beside it, mild and dry. The line between them is the front edge of El Niño's grip, and where it settles decides a great deal. That split has direct consequences for the country's water, its droughts, and its mountain snowpack, and those consequences are where the report turns next. The winter pattern El Niño builds does more than change the daily weather. It reshapes the country's water. Where the rain and snow fall, and where they do not, decides which regions see drought ease and which may watch it deepen. For a nation that lives and farms by its water, this is among the most consequential effects the pattern carries. Start with the good news in the southwest. That region is often dry and often in drought, and it sits under the wet southern storm track in an El Niño winter. Extra rain in the lowlands and extra snow in the mountains can bring real relief. Reservoirs that ran low through dry years get a chance to refill. For the arid southwest, a strong El Niño is one of the better hands the weather can deal, a season that tends to add water where water is scarce. California shares in that benefit, with a catch. The state depends heavily on the snowpack that builds in its mountains through winter, because that snow melts slowly through spring and summer and feeds the reservoirs and rivers when they are needed most. A wet El Niño winter can build a deep snowpack, which is exactly what the state wants. The catch is that the same storms can drop their moisture as rain rather than snow if they arrive warm, and rain runs off at once instead of banking for later. A wet winter helps most when the mountains stay cold enough to hold it as snow. That points to a real tension in a warming world. The global warmth that El Niño adds, laid on top of the longer warming trend, raises the odds that some winter storms fall as rain higher up the mountains than they used to. Rain on snow, or rain instead of snow, drains away quickly and can even trigger flooding, rather than storing water for the dry season. So a wet El Niño winter is a gift to the western water supply, mainly when it arrives cold. The warmer it runs, the more the benefit leaks away. Now the harder side, in the north. The same pattern that soaks the south tends to leave the northern tier dry, and that dryness reaches the places that store water as snow. The northern Rockies and parts of the upper country can see below normal snowpack in an El Niño winter, because the storms that feed those mountains track to the south. For river systems that depend on northern mountain snow, a lean El Niño winter can set up a dry spring and summer downstream. So El Niño does not simply end drought or cause it. It moves the water around. It tends to ease drought across the southern tier and the southwest, and it tends to withhold water from the northern mountains. One region's relief can be another's shortfall, decided by the same shift in the storm track. A person watching only their own state might see a wet winter or a dry one, and both would be El Niño at work, just on opposite sides of the line. The Pacific Northwest often lands on the dry, mild side of the pattern, which matters because it too banks its water in mountain snow. A warm, dry El Niño winter can trim the snowpack there, with effects that show up months later in the region's rivers and reservoirs. It is a clear example of winter weather writing a story that only finishes in the following summer, when the missing snow is felt as missing water. There is a timing lesson in all of this worth holding on to. The water effects of an El Niño winter are not felt only in winter. The snow that falls, or fails to fall, between December and February becomes the water supply of the spring and summer that follow. So the pattern reaches beyond its own season, seeding conditions that unfold long after the ocean has moved on. A dry northern winter is a quiet warning about the warm months to come. All of these water effects grow more pronounced as the event grows stronger. That raises the question that has been building through the whole report. How strong will this El Niño actually get, and what would it mean if it climbed into the rare, top tier the record reserves for the biggest events? The strength of the event, and the odds of a super one, is where the report turns next. The whole story turns on one open question. How strong will this El Niño get? Everything else, the wet south, the mild north, the quiet Atlantic, grows firmer or fainter depending on where the ocean tops out. Forecasters sought the answer into levels, and by the summer of 2026 the outlook was pointing toward the higher ones. The levels rest on how far the watched ocean climbs past its mark. A reading a bit above the line counts as a weak event. Push the season-long warmth higher, to around 2.5 to 3 degrees Fahrenheit above normal, and the event is strong. Higher still, to around 3.5 degrees above normal or more, sustained through winter, and forecasters reach for the word they save for the biggest events. They call it a Super El Niño. Super El Niños are rare. Only a handful appear in the modern record, and the two clearest peaked in the winters of the late 1990s and about a decade ago. Both reshaped a full season of weather across much of the planet and drove global temperatures to records. When forecasters raise the possibility of a super event, they are invoking that short and heavy list. It is not a word they use loosely. For 2026, the outlook leans strong with a real reach towards super. By the time of the advisory, forecasters were calling for the event to reach at least a strong level by fall, and they put substantial odds on it, climbing into the very strong or super range through the heart of winter. The models pointed the same way, with a large share of them projecting the ocean to peak near or above the super threshold late in the year. The event was not merely present, it was aimed high. The reason the ceiling matters is that a stronger event tilts the odds harder. A weak El Niño may pass with little clear mark on American weather, its signal lost in the ordinary noise of the seasons. A strong or super event pushes the winter jet stream firmly and steadily, and its fingerprints, the wet south, the mild north, the quiet Atlantic, show up more reliably and more forcefully. The bigger the ocean anomaly, the more the season bends to follow it. A super event does not just make the usual effects more likely, it can make them more extreme. The wet southern winters of the biggest past El Niños brought not just rain but flooding, not just snow but record snowpack. The global temperature spikes were not modest bumps but new records. If this event climbs into that top tier, the reasonable expectation is not a different kind of winter, but a stronger dose of the same one, with the risks at the wet and warm ends pushed further out. Forecasters hold one honest caution over all of this, and it is important. Even a very strong El Niño does not force any single outcome. A big ocean anomaly loads the dice heavily, but the atmosphere still has its own say, and other patterns can push back in a given month or a given region. The record includes strong events whose effects fell short of expectations in some places. Strength raises the odds of the classic pattern. It does not sign a contract. There is also the plain fact that the peak had not yet arrived. Through the summer, the event was still climbing, and its final strength would not be known until the fall and winter numbers were in. The outlook favoured a strong to super event, but that was a forecast of where the ocean was heading, not a measurement of where it had landed. The difference is the difference between a well-supported expectation and a settled fact, and forecasters kept the two apart. So the answer to the central question, by the summer of 2026, was this. A strong El Niño was highly likely, and a super one was a live possibility, with the outcome to be decided over the following months. Either way, the event carried enough force to leave a real mark on the American winter, with a super version leaving a heavier one. That heavy potential makes it all the more important to be clear about what El Niño can and cannot do. It tilts odds. It does not dictate days. Setting that honest limit around the whole forecast is the next piece of the story. For all its reach, El Niño has clear limits, and understanding them is as important as understanding its power. The pattern tilts the odds. It does not dictate the weather. Every forecast in this report rests on that distinction, and it deserves to be stated plainly on its own. Here is the heart of it. El Niño changes the likelihood of certain outcomes across a season. It makes a wet southern winter more probable, a mild northern winter more probable, a quiet Atlantic more probable. What it never does is guarantee any of them, in any particular place on any particular day. It shifts the deck. The individual cards still fall as they fall. The reason is that El Niño is one force among many. The atmosphere is pushed by other large-scale patterns, some of which change week to week and cannot be predicted seasons in advance. Any one of those can, for a stretch, override El Niño's tilt in a given region. So a wet-leaning southern winter can still hold dry spells, and a mild-leaning northern winter can still turn bitterly cold for a week. El Niño sets the background odds. Shorter-lived patterns write the daily story on top of it. This is why forecasters speak in probabilities rather than promises, and why that habit is a strength rather than a weakness. When they say the south is favoured to be wetter, they mean the odds are tilted that way, not that every county will be soaked. A seasonal outlook is a statement about likelihood across 3 months and a wide region. It was never meant to fix the weather of a single town on a single afternoon, and it cannot. History drives the point home. The record holds El Niño winters that followed the classic pattern closely, and others that strayed from it in one region or another. There are strong events whose effects landed almost exactly as expected, and strong events that fell flat in places forecasters thought were a safe bet. That spread is not a failure of the science. It is the honest range of what a probabilistic pattern produces. Same ocean, different details, every time. The variation traces to the fact that no two El Niños are alike. They differ in where the warmest water sits along the equator, in how strong they grow, in how the rest of the atmosphere happens to be arranged around them. Those differences steer the effects to slightly different places. An event centered a little farther east can favor a different region than one centered farther west. So even a confident forecast of a strong event carries real uncertainty about exactly who gets what. This limit does not make the forecast useless. Far from it. Knowing that the odds are tilted is genuinely valuable, the same way knowing a coin is weighted is valuable even when you cannot call a single flip. A region favoured to be wet should prepare for wet, and a region favoured to be dry should plan for dry, because over a full season the tilt tends to win out. The forecast guides preparation, it just cannot promise the outcome. The right way to hear every seasonal outlook, then, is as a shift in the odds, held with appropriate humility. The wet south is likely, not certain. The mild north is likely not certain. The quiet Atlantic is likely not certain. Each of those carries real weight, and none of them carries a guarantee. That is not the forecast hedging. That is the forecast being honest about a system too large and too complex to promise more. Holding that limit in mind protects against two mistakes at once. It guards against complacency, the idea that a quiet Atlantic forecast means no storm can come, and it guards against false certainty, the idea that a favoured wet winter must soak every corner of the south. The truth sits between, in the language of odds, which is exactly where forecasters have kept it all along. With that honest frame in place, the practical question becomes simple and calm. Given that the odds are tilted in known directions, what should people in the affected regions actually do? The answer is measured and standard, and it is the next piece of the report. Given a pattern this large, the sensible response is small and steady. El Niño does not call for alarm. It calls for ordinary preparation, done a little ahead of time, in the places the odds have flagged. The guidance is calm and standard, and it matches what official agencies advise for the same conditions every year. Start with the wet south, where flooding is the main concern. In a winter favoured to run wet, people in low-lying and flood-prone areas do well to know their risk before the rain arrives. That means learning whether a home sits in a flood zone, keeping gutters and drains clear, and knowing the routes to higher ground. The single most important rule during a flood is the plainest one. Never drive or walk into moving water on a road, because it is far deeper and stronger than it looks, and most flood deaths happen in vehicles. For the mountains and the storm track states, the concern is travel. A busy southern storm track means more rain, snow, and difficult driving across California, the southwest, and the southern tier. The standard advice holds. Check the forecast before a long drive, keep the vehicle fueled and stocked with warm layers and water, and delay travel when a storm is crossing rather than pushing through it. A trip put off by a day is a small cost against the risk of a highway and heavy weather. In the milder, drier north, the guidance flips toward the opposite risk, which is being caught off guard. A winter favoured to run warm and quiet can still deliver a sharp cold snap or a heavy snowstorm, and a mild season can lull people out of their usual readiness. The remedy is to keep the ordinary winter basics in place regardless of the seasonal lean. A stocked home, a charged phone, and a plan for a power outage matter just as much in a mild winter that turns briefly severe. Along the coasts, the hurricane guidance stands even in a quiet year. A below-normal Atlantic season lowers the count but not the need to prepare, because a single homegrown storm can still reach land quickly. Coastal residents do well to settle their plan before the season is underway, knowing their evacuation zone, keeping a few days of supplies on hand, and deciding in advance where they would go. That preparation costs the same whether the season is busy or calm, and it only has to matter once. For the heat that a strong El Niño can add, on top of the warming already underway, the advice is the familiar warm weather set. Through hot spells, the priorities are staying hydrated, finding cool or shaded air during the hottest hours, and checking on the people most at risk: the elderly, the very young, and those without good cooling. Heat is quiet and easy to underestimate, and a strong El Niño year tilts the odds toward more of it. Underneath all of these cites one habit that covers every region and every season. Stay tuned to official forecasts and warnings and act on them when they come. The seasonal outlook tells people what to expect over months. The short-term forecast and the warning tell them what is about to happen in the next hours and days. It is the short-term warning that saves lives in the moment, and it costs nothing to keep it within reach. None of this guidance is dramatic, and that is the point. El Niño is a slow, seasonal tilt, and the right response is slow, seasonal preparation. There is no need to stockpile against catastrophe or to treat the winter as a threat. The task is simply to notice which way the odds lean in your region, and to take the same modest steps you would take for any winter or any storm season, a little sooner and a little more surely. That measured stance fits the pattern itself, which unfolds over months rather than moments. The next natural question is about timing. When exactly does this event reach its peak, and how does the calendar of the months ahead lay out? That timeline is where the report turns next. El Niño runs on a calendar, and knowing that calendar makes the whole event easier to follow. This is not a pattern that strikes and passes. It builds, peaks, and fades over the better part of a year on a schedule forecasters can lay out in advance. Understanding the timeline turns a vague sense of what is coming into a clear sequence. The building phase was already underway through the summer of 2026. The ocean crossed its mark in late spring. The advisory came in June, and the warmth kept climbing through the summer months. This is the ramp, the stretch where the event gains strength week by week without yet delivering much weather a person would notice. The engine was revving. The car had not yet reached the road. The strengthening was expected to continue through the fall. Forecasters projected the ocean to keep warming through the autumn months, pushing from strong toward possibly very strong or super as the year drew toward its close. This is the stretch where the tropical effects sharpen and the winter jet stream begins to organize. The fall is the on-ramp to the main event, the season when the pattern locks into the shape it will hold through winter. The peak was forecast for late in the year and into winter. The outlook called for the highest ocean temperatures around the turn from fall to winter and through the heart of the cold season, roughly the stretch from late in the year into the early months of the next. Forecasters placed very high odds on El Niño conditions continuing through that winter window. This is the summit of the event, the point of maximum warmth in the ocean and maximum push on the atmosphere. That timing lines up exactly with El Niño's grip on American weather, and the alignment is not a coincidence. The ocean peaks in winter, the winter jet stream is at its strongest, and the two reinforce each other. The pattern reaches its greatest strength in the ocean at the very season when the atmosphere is most able to translate that strength into weather across the country. Peak ocean and peak influence arrive together, in winter, by the nature of the system. So the calendar of the event reads as a slow rise toward a winter summit. Summer was the ramp, quiet on the ground. Fall was the strengthening, when the pattern took its winter shape. Winter was the peak, when the ocean ran warmest and the effects on American weather were expected to be clearest and strongest. Anyone following the event could mark those stages and know roughly where in the arc they stood. There is a reason forecasters can lay this out with confidence, and it comes back to the nature of the pattern. El Niño is a coupled, self-reinforcing system, the kind that moves steadily in one direction once it sets off. That steadiness is what makes the timeline predictable. A pattern that reinforces itself does not lurch or reverse without warning. It follows the arc, which is why the calendar could be sketched months ahead. The timeline also sets expectations for how the winter would actually feel. The classic effects, the wet south, the mild north, the quiet remainder of the storm season, were expected to be most pronounced through the winter peak and to ease as the peak passed. A person in a favoured region would be most likely to see the pattern in the deepest part of winter and less so at the edges of the season. The calendar and the weather run on the same clock. Knowing the peak also frames the question of what comes after it. An event that crests in winter does not simply switch off when spring arrives. It winds down, and its effects linger in ways that reach into the following year. That aftermath, the long tail of a strong El Niño, is the next piece of the story. An El Niño does not end when it peaks. It winds down slowly, and its effects reach past its own life, into the seasons and even the year that follow. Understanding that long tail completes the picture, because the story of this event does not finish when the ocean starts to cool. It finishes well afterward. The winding down tends to come in spring. El Niños typically peak in winter and then weaken as the following spring arrives, the warm water in the Pacific gradually giving way as the trade winds and the ocean's own rhythms reassert themselves. So the expectation for this event was a peak around winter and a decline through the spring that followed. The ocean climbs to its summit, holds briefly, and then eases back toward neutral over the months after. But the atmosphere lags the ocean, and that lag is where the tail lives. The clearest example is global temperature. As noted earlier, the peak warming of the whole planet from a strong El Niño usually arrives after the ocean event itself has crested, often in the following year. The heat the ocean released has to work its way through the atmosphere, and that takes time. So the biggest temperature effect of the 2026 event was expected to show up in the year after, even as the El Niño itself was fading. That is why forecasters were already pointing toward the following year as a likely candidate for record global warmth. A strong El Niño peaking in one winter tends to leave its temperature mark on the calendar year that follows, once the lag has played out. Laid on top of the longer warming trend, the setup pointed toward elevated global temperatures well into the year ahead, with a real chance of a new record, though the final ranking would not be known until the numbers were counted. The water story carries its own tale on land. The snowpack that builds or fails to build during the El Niño winter becomes the water supply of the following spring and summer. A deep western snowpack from a wet winter feeds rivers and reservoirs for months after the storms have stopped. A lean northern snowpack sets up a dry, warm season downstream, so the winter weather writes a water story that only fully reads out in the seasons after the pattern has moved on. There is also the matter of what follows El Niño in the cycle itself. The pattern often swings toward its opposite, the cool phase, in the year or two after a strong warm event, though the timing and the certainty of that swing vary and are hard to forecast far ahead. Forecasters watch for it, but do not assume it. What is reliable is the winding down of the warm phase through spring. What comes next, whether a return to neutral or a swing toward the cool phase, is a separate question answered later. For the person living through it, the practical meaning of the tale is patience. The effects of a strong El Niño are not fully spent when the winter ends and the headlines fade. The warmth lingers in the global average, the water lingers or fails to linger in the mountains, and the atmosphere takes its time returning to balance. Judging the full impact of the event requires waiting out that tail into the year that follows. This long reach in time mirrors the pattern's long reach in space. Just as El Niño touches places thousands of miles from the warm water that drives it, it touches seasons long after the ocean has begun to cool. It is a pattern that does not respect tidy boundaries, in distance or in time. Its influence spreads outward and stretches forward, well past where and when it seems to belong. So the complete arc of this event runs from the first warm signals in spring, through the summer ramp and the fall strengthening, to the winter peak, and on into a spring decline with a tail that reaches into the following year. That full shape held in mind is what it means to understand an El Niño, rather than just to notice one. With the whole arc in view, the report can close by returning to where it began, to what is known, what remains uncertain, and what to watch for next. The story began with 4 quiet words, and it is worth returning to them. El Niño conditions are present. On June 11th, 2026, the country's forecasters said them, and everything in this report has followed from that plain announcement. Now, with the whole arc in view, it helps to gather what is settled, what is still open, and what to watch as the event runs its course. What is confirmed is the event itself. El Niño arrived, declared by an official advisory, after the tropical Pacific warmed quickly through the spring and crossed its mark. The ocean in the watched stretch ran clearly above normal and was still climbing through the summer. That much is measured and certain. The pattern is real, it is present, and it is strengthening. There is no ambiguity about whether El Niño is here. It is. What is confirmed, too, is the general shape of its influence, because the record is deep and consistent. A strong El Niño tends to bring a wetter, cooler winter to the southern tier, a milder, drier one to the north, a quieter Atlantic hurricane season, a busier eastern Pacific, and a bump in global temperature that lags into the following year. These are not guesses. They are the well-worn tracks of past events, and this event has the size to follow them. What remains uncertain is the strength and the details. By summer, the event was strong and reaching toward the top tier, but whether it would climb into the rare super range and exactly where it would peak could not yet be known. Nor could the specifics of who gets the heaviest rain, the sharpest cold, or the deepest snow, because those depend on where individual storms track through the winter. The pattern was clear, the particulars were still being written, and what remains genuinely open is the honest limit that has run through this whole report. El Niño tilts the odds. It does not dictate the weather. Even a strong event can fall short of expectations in a given place, because the atmosphere has other forces at work and no two El Niños are alike. The forecast is a statement of likelihood, held with humility, not a promise of any single outcome in any single town. So what should a person watch for next? The clearest thing to follow is the strength of the ocean through the fall, as the reading in the watch stretch either climbs toward the super threshold or levels off below it. That number, updated regularly by the country's forecasters, is the truest gauge of how firm the winter's grip will be. Watching it is watching the event decide how large it will grow. The second thing to watch is the winter itself, as it arrives, region by region. Whether the south turns wet, whether the north turns mild, whether the storm track settles where the odds suggest, these will be answered not by the outlook, but by the weather as it comes. The seasonal forecast set the expectation. The winter will report the result week by week across the country. For now, the country sits where it sat in June, only further along the arc. El Niño is present, strengthening, and still building toward a winter peak, with its clearest effects on American weather still ahead. The summer was quiet on the ground, as expected. The main act is the cold season, and it has not yet been played. The event is far from over in the plainest sense. Its largest chapter is still to come. That is where this report leaves it, with the pattern set, the odds tilted, and the winter waiting. There is nothing to fear in the waiting and much to understand, which is the whole aim of watching the Earth this closely. The next report will pick up the story as the season turns, and follow El Niño into the winter it has been building toward all year.